Very good morning. This is ARULMURUGAN from Kongu Engineering College. Today's session we are going to see about addressing modes in 8086. The first of all, what is meant by addressing modes means it's a way of representation. The way of data is represented in the instructions. How we are going to represent the operand in the instructions, that is called by an addressing modes. Okay, there are 5 different types of addressing modes is there. The first one is the immediate addressing mode. Second one is the direct addressing mode. Third one is register addressing mode. Fourth one is indirect, and then finally the implied addressing mode. The first of all, let me discuss about immediate addressing mode. So the immediate addressing mode is nothing but the data comes along with the instruction. That means the data is represented within the instruction itself. Data in instruction. Data in instruction. For example, we can say move AL comma 35H. AL comma 35H. So AL is an 8-bit register, 35 is an 8-bit value. That means 35 is directly moves to AL register. The 35 is a data that is directly moves to AL register. AL is an 8-bit register. So this is an 35 is an hexadecimal value. We can represent 0, 111, 5 we can represent as 0, 101. So it's an 8-bit value. This 8-bit value was directly moves to the AL register. So, for example, let me discuss about 16-bit value. Move BX, 1234H. So, what is the meaning? The data 1234 is moves to BX register. 1234 is a 16-bit value. BX register is a 16-bit value, 16-bit register. So, the 16-bit data is moves to BX register. One more example. See here, move AL, 3567H. This was not possible. Why? Because 3567 is a 16-bit value. That is the 16-bit value can't able to move 8-bit register. Why? Because AL is an 8-bit register. In 8-bit register, we can able to accomplish up to 8-bit only. So 16-bit is not possible. Okay, the next we are going to discuss about the next addressing mode, direct addressing mode. Okay, the next one is a direct addressing mode. So direct addressing mode is nothing but the address is mentioned within the instruction. That means address in instruction. Address in instruction. For example, move AX, 2000H. So what is the meaning? Whatever the content is located in the 2000H memory location, that is moves to AX register. For example, consider this was in 2001. For example, I have in the 2000 memory location 55. In 2000 memory location, I have 35 the data. So the AX move AX, 2000H means the content which was stored in the 2000 memory location and then 2001 memory location, that is moves to AX register. Why? Because means AX is a 16-bit register. AX is a 16-bit register. It will be accomplish the 16-bit values. In the 2000, the 55 is an 8-bit value, 35 is an 8-bit value, 55 is an 8-bit value, 35 is an 8-bit value. In the AX was, we will classify AH and then AL, AH and then AL. So in AL it will be stores 55, AH it will be stores the 35, AH it will be stores the 35. So one more example we will discuss about move BL, 2000. So what is the meaning? Means the whatever the content is located in the 2000 memory location, that will be moves to BL. BL is an 8-bit value. BL is an 8-bit register. So whatever the content is available in the 2000 memory location, that means 8-bit value. Here here I stored the 55. That 55 was moves to the BL register. That is moves to the BL register. This was a direct addressing mode. One more example, move BX, 3000H. So what is the meaning? Whatever the content is available in the 3000 memory location, that is moves to BX register. So whenever we are representing the data within the square bracket, it will be considered as an address. So move AX comma square bracket 2000. So it will be considered as an address. So whatever the content is available in the address location 2000, that is moves to AX register. In case if I didn't mention move AX comma without square bracket, if I am mentioning, means it will be considered as a data. Okay. The next one is the register addressing mode. Actually, first what we have seen, immediate addressing mode. In this immediate addressing mode, the data is represented in the instruction. The data is mentioned in the instruction. Then direct addressing mode, the address is mentioned in the instruction. The next one we are going to see about register addressing mode. In this register addressing mode, the data is mentioned in the register. Data is available in the register. Data is available in register. Data is available in register. For example, move AL comma BL. So what is the meaning? Whatever the content is available in the BL register, that will be copies and moves to AL register. This was an 8-bit. For example, if you want to say in the 16-bit, move AX comma BX. So what is the meaning? Whatever the content, that means 16-bit values, it's available in the BX register, that is moves to AX register. For example, move AL comma BX is not possible. Why? Because means BX is a 16-bit register, so it will be having 16-bit data is available in the BX register, that is not moved to AL register, so this is not correct. Okay. The next one more example, let me see. Move AX comma exchange AX comma BX. What is the difference between exchange and move? Means exchange means simply it will be exchange the data from one register to another register. Whatever the content is available in BX, that is moves to AX register, as well as whatever the content is available in the AX register, that is moves to BX register. In this exchange, simply the data will be moves from BX source to destination, and then destination to source, it will be exchange the data. The next one is the indirect addressing mode. In this indirect addressing mode, totally there are 4 types is available. The register indirect addressing mode, relative addressing mode, base index addressing mode, relative based index addressing mode, and then finally the implied addressing mode. The first of all, let me discuss about register indirect addressing. For example, move AX comma BX. So already I told with you, whenever we are representing within the square bracket, it will be considered as an address. So the BX points some address location. Okay, now the BX points some address location. Whatever the content is available in the BX points address location, that is moves to AX register. That is called by a register indirect addressing mode. So we can say address in register. So in the BX registers having some address, that will be point certain value, that will be moves to AX register. For example, directly we can't able to write move AX comma BX. Initially we need to assign the BX address path. So move BX comma 2000. For example, move BX comma 2000. So BX initially I am assigning BX value was 2000 H. The next what I am going to do means move AL comma BX. For example, I put here AL comma BX. So the BX was initialized as a 2000 H. So the BX act as a memory pointer. Whatever the content is available in the 2000 H memory location, that is moves to AL register. For example, see here in 2000 H I stored as a 35 as a data. 35 as a data. Here I called BX as an indirectly I have called BX initialization 2000. So whatever the content is available in the 2000 address, that was moves to AL register. This is called by a register indirect addressing mode. The address was stored in the register. The next one is we are going to see about in the indirect addressing mode. We are going to see about relative addressing mode. So already I told with you in indirect addressing mode there are 5 types is available. One was register indirect. The next one was relative addressing mode. This relative addressing mode is nothing but register addressing mode. register indirect addressing mode comes with a displacement value. For example, move AL comma BX plus 2. So what is the meaning? Actually already I assigned my BX as an 2000. For example, move BX comma 2000. So my BX acts as a memory pointer. Move AL comma square bracket BX plus 2. So it will be represents 2002. So directly I am going to access whatever the content is available in the 2002 memory location, that is moves to AL register. In the 2002 memory location I have stored as a 15. So the 15 is moves to AL register. Like that we can write BX plus 5, BX plus 9, like that we can able to write. So this is called by a relative addressing mode. Relative addressing mode is nothing but register addressing mode comes along with the displacement value. That 2 is here, the 2 is here displacement value. One is index addressing mode. So index addressing mode means we need to exchange the data between the register and then index registers. There are two index registers is available. One is the SI register, another one is the DA register. That means source index register, another one is the DA register. For example, move AX comma SI, AX comma SI, or move. This was if you want to move the 16-bit value means move AX comma SI. Otherwise, if you want to the 8-bit value means you can, instead of AX you can use AL. Like that, move BX comma DI or AX comma DA. So whenever the data is moves from the index register to index register address to general purpose register, we will call it as an index addressing mode. Index addressing modes. The next one is the relative based index addressing mode. Here the base address, it may be an BX or BP, will be used in case if you are going to access the data memory, we will use an BX. In case if you are going to access the stack memory, we can use as an BP, we will use, that means base pointer we will use. For example, BX is 3000. Actually I want to access my data from 3082. In 3082 I have the data 32. I want to access means I will be assigned my base register value was 3000, and then I will assign my SI was 80, my source index was value was 80, and then plus displacement value was 2. So 3082, whatever the content is available in the 3082 address location, that will be moves to the AL register. That means here I have stored the 32, that will be moves to the AL register. This is called by a relative based index addressing mode. The last one is implied addressing mode. The last one is the implied addressing mode. The implied addressing mode is nothing but the instruction itself, the operand was implied. For example, CLC, clear carry. So there is no memory, there is no register, there is no address is available. The operand itself implied. So CLC means clear carry, STC means set carry, and then clear direction flag. That means whenever if you want to increment the auto increment, we need to make as an clear direction flag. Set direction flag. If you want to make as an auto decrement, so we will use a set direction flag. This is called by an implied addressing modes. So the addressing modes are totally 5 types is available: immediate, direct addressing mode, register addressing mode, indirect, and then implied addressing mode. In this indirect addressing mode, we will classify as an 5 different types. One is an register indirect addressing mode, and then next relative addressing mode, index addressing mode, and then finally relative base index addressing mode. That's all. Thank you so much.